Hello and welcome back. This is the final video in our series, and it's a big one. We're going to talk about how we can take our separate parts and assemble them together into working products or working machines. So let's go ahead and get on into it. So the first thing I want to note is that when I go to start a new assembly, it is its own file. We have a standard assembly. We also have weldments, which is a different type of assembly that utilizes welds. What we're going to stick to is the standard assembly. So I'm going to go ahead, click on that, and open it up. Now, the thing to remember in assemblies is that we are bringing in all of our different components into this particular file. So every part I create that goes into a machine, I will at some point load or place into my assembly file, and then I will put it together inside of the assembly file. And when we get to putting things together, there are a couple different ways that we can do this. One is with constraints, and that's the way that I'm going to show in this particular video. There's also a way or another command that we can use called joint, and joint gives us some different options for some typical joints that we see inside of machines. The main difference between constraint and joint is that with constraint we're controlling every aspect of how that component moves. Joint kind of has some predefined setups for them. So for example, like it has a ball joint hinge. It also has a regular hinge. So it has some predefined assemblies that we can use, or some predefined joints. With constraint, like I said, we're controlling each aspect of it. So constraining is what we're going to be looking at today in this video. First things first though is how do we get our parts inside of an assembly? Well, up here in the top left under our Assemble tab, we have Place. So if I click on Place, it's going to bring up every single part that we have made, and then of course going to different areas, I can pick different files to find my parts. So from here though, let me find my parts I've created. I am going to drop in a couple different parts. Those out there. So we have to select the parts that we want to drop in, and from there we can start assembling them. I went ahead and I have two different nickel cubes here. I've got two little copper tubes and two aluminum cylinders, and with these different parts I'm going to show how the different constraints work. So go ahead, I'm going to click on Constrain, or the C key is the shortcut, and inside of my constraint menu you can see we have a couple different types of constraints available to us. We have the mate constraint, we have the angle constraint, we have the tangent constraint, the insert constraint, and the symmetry constraint. So those 5 different types that we can utilize. Now inside each of those types there's a couple of different solutions for each one of those constraints. So for example, we have mate selected right now. I can do a mate, or I can do a flush mate. And the neat thing about Inventor is those solutions kind of show us how the solutions are going to work. So for example, if I look at mate here, mate shows two different blocks joining together face to face, and that's exactly what the mate solution does. So as an example, if I click on my face there, then say click on this face of my cylinder, you'll notice that they're now stuck face to face. So I'll hit apply and X out of my menu. And you'll notice that they can move, they still move, but they're going to be joined at those faces. Now, with that, if I go to my top view here, just because those faces are joined, they're not joined to the actual surface itself. Think more on a plane-to-plane type of level. So, I can move my pieces off of each other, but you'll still notice that the planes of those two faces are still constrained. Alright, let's go back to the home there. So there's an idea of how the make constraint works. Same thing if I went in and say did a mate between the face of my cylinder and the face of this other cylinder. I'll rotate around here, put that down, and you'll see I can still move it about, but those two faces, or the two planes of those faces, are now stuck together. Quickly undo that. Now, anytime we place a constraint, just like everything else that we've talked about up to this point, it is shown inside of our model tree. So if I go under my test cube 1 here, you can see there's that mate constraint that I put down. And just like anything else, I can double click or right click and edit that particular constraint. Now, if I double click on it, it's automatically just going to pop up with the offset distance. And kind of similar with if we use a tangent or any type of other constraint, it will just give us the input value. So from here, we can quickly change any of those inputs. But what I want to do is I want to right click and I want to go to edit to bring back up that constraint menu. Now in here, you'll see we have an offset. So if I highlight that and say change that to 1 inch, you'll notice that I now have a 1 inch spacing between my two cubes. Let's go back to home up here, and I can confirm that if I go here, then here with my measure tool, and they're exactly 1 inch apart. So we can control the distance away from those faces, as well as if we wanted to, let's see, if I right click and go into edit, I can change that to a -1. And now they overlap by 1 inch. So we can go in two different directions with that. We'll back up there, and I'm going to go ahead and delete that constraint. So that's the make constraint. So I'm going to go back up into my constraint menu, and I'm going to look at the other solution because to be honest, mate is probably one of the most common constraints that we use. And the nice thing is it doesn't have to be a face or a piece of the model. I can use work planes that I create. I can use the origin planes that are already built into my parts. I can use axes, edges, pretty much the sky's the limit with the make command. We can use almost any type of geometry. Now, kind of remember back to the very beginning of our video series, I talked about always centering our sketches around the origin, and now we've come full circle. This is why we do that. This is why we ground our sketches to the origin. Because if I go in to the origin folder of my test cube 1 here, I've centered my part on the origin. So I'm going to zoom in again and do that. So my origin planes cut through the center of my part. Same with my X, Y, and Z axis, and the center point is at the dead center of that cube. Now we should start seeing why we do this. This allows us easy access to mid-planes if we need them, or a mid-axis, or the very center point of a part. So hopefully the light bulbs are clicking off in your head now. That's why we constrain things to the origin and try to center it around the origin. So now I'm going to go ahead and talk about a few of the other constraints. So I'm going to go ahead and talk about the solution for flush under the mate type. Because again, we use mate a lot, so it's good to understand what mate and flush are. So I'm going to go ahead and I'm going to click this surface, and then I'm going to click this surface. Hit OK. And I'm going to go to my top view. Now you can see with my flush, I made those two planes flush with each other or in line with each other. So now as I move that, you can see that that edge there and the edge here are always going to align with each other. Now if I go in to that flush and let's change that to 1 inch, go back to my top view, there I have that 1 inch offset. Those two planes are still going to be parallel to each other. Now I just have distance between them. So hopefully you're kind of getting the idea, I'll undo that, of the mate constraint. Now if I look at angle, angle's a tricky one because angle's got 3 solutions. There's a lot of different ways that we can use it. I typically use directed angle because in my mind that makes the most sense. But we can set angles between two different surfaces or faces or planes, whatever you want to call it. Tangent is another one that we see a lot of use for. Now with tangent, we have 2 different types of solutions. We have an inside and an outside tangent. By default, it is an outside tangent, so if you need an inside, you'll have to swap that. But the idea is, and we can see that by our solution pictures, we can make things tangent on the outside of the edges or tangent inside of the edges. So I'm quickly going to show, if I use my cube here, and that outside of my cylinder there, to do an outside tangent. So I'm going to hit OK, go to my top view, and you can see, and I've got my other cube still flush, so we can kind of get an idea of how everything interacts with each other. So cube 1 here is tangent to cylinder 1. I still have my other cube that's flush with this one, so moving it along that tangent, I'm still going to move my other cube. This is how we get machines to actually mimic their motion or simulate their motion inside of Inventor. So there's that. Let me switch back here. Now I'm going to right click and I'm going to edit that tangent. So now I'm going to take that, I'm going to flip it to an inside constraint or an inside tangent. So if I hit OK, you should have seen it move already, but if you look now, that edge is tangent to the inside of that cylinder's curve. So you can kind of see that there. So you can kind of see at what I'm getting at for our different constraints inside of the assembly files. So I'm going to go up to my constraint again, and really the last one I want to truly focus on, but I'll talk about symmetry as well, but I also want to focus on the insert constraint, because insert is kind of a 2-for-1 constraint. Insert basically doubles as a axis-to-axis constraint and a face-to-face constraint all in one, and we use it for rounded pieces. So any type of shaft assembly we're going to use insert for. Now I'm going to go ahead, and if you see, we have 2 different solutions. We have opposed and we have aligned, and if I click on my cylinder down here, something you should notice is it gives it an arrow. That arrow indicates the side that's going to be used in the constraint, and if you look at the solutions, it shows how those arrows point. So opposed, our 2 arrows are going to be pointing at each other. If it's an aligned insert, the 2 arrows are going to align with each other. So I'm going to quickly show you the difference. So I've got my cylinder picked. Now I'm going to pick this top circular edge of my tube. And you'll notice, I'm going to hit OK, that it lines it up at the very top of that tube. Now, this is where the kind of 2-for-1 comes in at, because that cylinder is now in line with the center of that circular reference. It is also tied to that circular reference so that it doesn't move up or down. So you see we get two mates for the price of one, basically. But you're probably saying, well, okay, how is that useful? If we need to, we can set offsets. So if I do 1, you should see it gives a preview of that going 1 inch away from my tube. Now if I change that to a -1, you'll notice I'm now an inch inside of that tube. So you kind of see where I'm going with this. We can control exactly how far we need shaft and hole systems to insert or be apart from each other. Now I'm going to go ahead and I'm going to delete that particular insert, and now we're going to look at an insert with an aligned solution to it. So again, I'm going to pick my face that I did before. If I look, my arrow is pointing down. Now I'm going to pick that same edge as before. Hopefully you notice the difference. As I said, aligned makes the arrows align with each other. So now the arrows of both of my pieces that I selected are facing the same direction. And if I give it an offset, you can kind of see how we can control that. Let's give it a -1. So now I've inserted that cylinder into the tube. So hopefully that gives you an idea of how the basics of our constraints work. So there are those 5 different types that we can utilize. The last one, which I said I was going to show you real quick, is symmetry. And we can use symmetry to basically replicate things or make sure that two objects are the same distance from a given plane. Almost kind of like a mirror, but we have to have both parts there. So if I were to make, let's say, let's delete some constraints off of this one here. There we go. Move those 2 cylinders out. Okay, so now if I were to go in with a symmetry, I want them to be opposed. So I'm going to pick my first face. I'm then going to pick my second selection and then my symmetry plane. So if you kind of follow the selection tools up here, it'll tell you what you need to pick. So there's my second, and up here I'm going to go into the origin of my actual assembly file, and let's pick the XY plane and hit OK. So now, neat thing is, these things are symmetrical across the plane. So if we go up to the top here, manipulate this way, you'll notice as I move one closer to that symmetry plane, the other one follows. Now, it doesn't do anything if I move in the other 2 directions, but if I move to or from that symmetry plane, you can see I can control the other side. So like I said, kind of similar to a mirror command. But those are the 5 kind of basic types of constraints. Now we're going to focus and take what we just saw in this little preview that I showed you, and we're going to assemble together a small little base plate with a bearing and some cap screws. So I'm going to go ahead and close this, and I'll see you on the other side. Okay, so I've got my new assembly file ready to go. One thing that I want to show you first before I start placing my new parts into this assembly file is how we set up to make sure that our first component is grounded at the origin of our assembly. So you might be thinking, okay, well, what's the point of that? The point of that is our first part needs to be grounded, or else our entire assembly is going to be moving out in 3D space, and then we won't be able to use the origin point itself or any of our planes or axes if we need to. So we always want to make it a practice to make sure that our first part is always grounded at the origin. And to do that, you'll go up into your file, go into options, and pull that over here. Inside of our options, I'm going to go to assembly, and the option here to place and ground our first component at origin, you want to make sure that one is checked. That will automatically do the work for you, so you won't have to try and figure out how to place it there at the origin with constraints. So I'm going to go ahead and hit OK. Now, whenever I place that first component, you should see that it grounds it at the origin. So I'm going to go ahead and hit place. I'm going to use a base plate here. And when I click it, you'll notice it automatically drops that part for me. I don't have to click to place it. So, and if I look, that part there has a little push pin over its symbol. That means the part's grounded. I can't move it whatsoever. It is frozen in place. So always remember, whenever we're putting assemblies together, you always have to have a part that is grounded so that everything else doesn't move. Ideally, you want that to be your first component you drop into an assembly. And we want to make that first component something that's important to our assembly file. So for the longest time, I designed storage tanks, chemical tanks, oil tanks, that sort of thing. When I would design one of these, I always grounded my shell, because every tank has to have a shell. You can't really have a tank without a shell. So it was an important part or component of our overall assembly. So whether that be a vertical tank or a horizontal tank, I always added that as my first component and had it grounded because I knew I was going to need it. So that's kind of the idea whenever we place our first component. So I'm going to go ahead and place the rest of the components, and I'll see you on the other side. Okay, got all my components placed. Now, we're going to utilize what I just demoed, and we're going to put this little assembly together. So I have my base plate here. The first thing I want to add is I want to move and place my bearing. So what I'm going to do, I'm going to go in with a mate command, or a mate constraint, and I'm going to mate the bottom of my bearing to the top of my base plate and hit apply there. Now, something I want to mention while we're getting into actually using the application. There is a command in here that will show us the degrees of freedom of each individual part of an assembly. Now, you might be wondering, okay, what's degrees of freedom? Degrees of freedom is how the part can move or rotate inside of our 3D space. So every part has degrees of freedom, and there's 6 of them. We can move in the X, Y, or Z direction, and we can rotate in the X, Y, or Z direction. So of those 6, the idea is when we are creating these parts to eliminate all of those degrees of freedom. Now, if you're going to simulate a machine or simulate a product that's working, you don't want to eliminate all of those degrees of freedom. But in our case, since we are making technical drawings from our models that we create, it's always best to make sure you lock down all the degrees of freedom. Otherwise, you're going to be using some memory and RAM that you don't really need to be using on your machine. So from here, I am going to go into my view, and under the View tab you should see a Degrees of Freedom command, or Control-Shift-E is the shortcut for it. Hit home here. Now when I do that, you should see 3 arrows and 3 little rotational arrows for each part. That means I can move in all directions and rotate in all directions. Now if you look at my bearing, I've eliminated 3 different degrees of freedom. I can no longer move in the Z direction. I can move in the X and Y direction, but I can no longer move in the Z direction. And if I go to the front, you can see I can't do that. So that arrow has been eliminated off of my part. But I can no longer rotate around the X or Y directions. I can still rotate in the Z direction because there's nothing limiting me from doing so. So as we go along, you'll notice these different degrees of freedom slowly going away as we add constraints. So from here, I'm going to go ahead and I'm going to use a different kind of use of mate that I didn't show you in the demo. And like I said, we can use mate on just about everything. So what I'm going to do, I'm going to click on the inside of my hole of the bearing. And you should see it gives me the preview for that center line, or that center axis. So I'm going to click on that, and I'm going to do the same here. And I'm going to hit apply. You should notice I no longer have the ability to move this guy in the X or Y direction, or the Z direction. And I can't rotate it in the X or Y direction either. All that's left is I can rotate it in the Z direction. And so to eliminate that, all I have to do is go in and do that same constraint again from axis to axis on those other bolt holes. Now that part can no longer move, and it's in its proper location. So from here, I'm going to go ahead and I'm going to do this to the rest of the parts to finish up my full assembly. So as I do that, experiment with the different types of constraints. Mates may not work where you might want a tangent. Tangents may not work where you could use an insert. So it just takes a lot of practice with these different constraints to really get comfortable with them. So I'm going to go ahead and, like I said, constrain the rest of these parts down, and I will see you on the other side. Okay, so I went in, fully constrained some things. You might have noticed as I was going through and constraining all that stuff down that I did go in and I utilized some of those center planes. And that is absolutely okay. There's no rule saying that you have to use all surfaces or all work features. You can intermix them as you need to. So here I have my fully constrained little assembly. Now, next thing I want to do is I want to take this into a drawing, and I want to show you how we can create parts lists and balloon out all the different parts on an assembly. So let's go ahead and dive on into that drawing. And first things first, before I do that, I want to come in here and I want to save, and I'm going to just save it as assembly 2. And once that's saved, head back to my drawing. There we go. So just like a part, I'm going to go in, I'm going to use my base view, and I'm going to pull up the different views of my assembly here. And let's go ahead and shade that one. Now, we've all seen, hopefully seen anyways, instructions before. whether that be instructions for a Lego set, for putting furniture together, or if you've actually seen full-blown technical drawings. We always have a page that lists out all the parts that are involved in putting whatever it is we're putting together. That's known as a parts list. And parts lists are very, very easy to create in Inventor. And I'm going to show you how. So, first thing I want to do, I'm going to go to my Annotate tab. And over here, underneath the table, we have, lo and behold, a parts list command. So I'm going to click on parts list. From here, it wants us to select a view, so I am going to select the base view of my assembly. And from here, we can kind of change the structure of our BOM or our parts list. Now, for right now, I'm not going to get too detailed into this. Later on, I will probably put a video together showing all the different things we can do with this. But for now, we're just going to leave all the settings as default. So, needless to say, you can change your structure and the settings and properties of your parts list here. And table wrapping means that after so many entries into the parts list, it will stop and continue either to the left or right, depending on what we select here. So that is allows us to wrap the table if it gets too long. So we can control that here. But I'm going to go ahead and hit OK. And it's going to tell me I need to activate my BOM or Bill of Material view in my assembly. I'm going to select OK because I do. And once I do that, you should get a box. And I'm going to click and place that box. And what that does is it drops in a parts list for us. So now each part has a designated item number with it. It tells me how many quantities of each part are present inside of this assembly. It gives me the part number, a description, and we can also add in other things like material. If we want to have a stock number, we can include that. We can include even custom columns into these parts lists. And this is just a very generic looking parts list because honestly, each company out there is going to do things differently in their parts list. It's going to be very rare that two companies do the exact same thing. And that's okay because we can customize how we want these parts lists to look. But I'll quickly show you how we add in a new column to our parts list. So like anything else in Inventor, I can double click on my parts list and it brings me into the parts list editor. And in here, kind of like Excel or Google Sheet, I can go in and I can just select on different cells and change things. But if I want to add in a column, I need to go to this first button up here that says Column Chooser. And in the Column Chooser, I have all my available properties here, and these are the ones that are shown inside of my parts list. So if I want to add in, say, material, for example, to list the material of each part, I'm going to go down, find material, and then I'm going to add it to my parts list. Now from here, I can move it up or down as needed. I'm not going to worry about it. I want it to stay on the end. Now if I wanted to add in a custom property, I can click New Property and it will have me add in a custom one. So I would just click up there and type what it is. But like I said, I'm not going to worry about that. I just want the material. So I hit OK. Once I do that, you should see it gives me the material in my editor. So I'm going to hit OK, and there we have it. We added in that material. So pretty painless, right? We don't have to go in, type in everything by hand. None of that. It can go in, it creates the table for us and populates it with all the necessary information of that part. Now, like I said, there's more to it than what I'm just showing you here. In the future, I said I will probably make a video that details some of the more advanced functions of the parts list, but for now, this is just giving us a general idea of what we can do. So now, I have a parts list. Next thing I need to do is identify each of the parts in my assembly. And somehow I just noticed this thing does not have hidden lines. Let's go ahead and change that. There we go. So first thing I want to do is identify the parts in my assembly. And to do that, we have what's called a balloon, or the B is the shortcut for it. Balloon just pulls off an identifier that allows us to, as it sounds, identify the part. So I'm going to click on balloon here, and I'm going to select my bearing. And it tells me bearing is item 3, and that corresponds with my parts list. And the neat thing is, if I change the number in the parts list, or if I change my item number by editing my balloon, it will update in either the balloon or the parts list, vice versa. So there's that adaptability that Inventor has. So if I go in here, and if I click on each of my parts, and I'm just double clicking to place it, and we'll do one for the bearing itself. There I've properly identified all the parts of my assembly. And so I can go into the other views and do the same thing. So really, it's pretty easy. Not a whole lot to it. You're just clicking and identifying each of the parts there. So, I mean, that's basically what I want to cover in this introduction to assemblies. This is going to take you a long ways when it comes to putting all of our parts together, coming up with technical drawings for them. And like I said, this is just a glossing over the surface. There's a lot more intricacies that we can cover later on when it comes to assemblies and parts lists and everything else. But I'm glad you stuck with me through this entire series. I mean, hopefully you've learned something along the way, enjoyed yourself. I'm going to be putting out more videos that covers more aspects of design, and I hope you take the time to check those out. So again, thank you. If you enjoyed the video or the video series, please give it a like or give me a subscribe, and as always, be inventive.